Hello, this is the second lesson of March 30th, translations. We've done the first couple of sheets. You should be on this one now. This one is not paramedic. It is not piecewise. It's a cubic, form of a cubic. It's just more complicated, harder to do. We're going to do this transformation. It's actually called a translation. Because it's in the bracket, it's going to be a horizontal translation 3 units to the left. Harder to do, it's a curve. Move some critical points. 1, 2, 3. We'll move that one. This one here, 1, 2, 3. This one here, 1, 2, 3. And I'm going to connect them. This one, 1, 2, 3. This one, 1, 2, 3. And then I'm going to make a nice smooth curve. When I'm done, they should look the same. And since they're not straight lines like before, it becomes awkward. Label it. This one was y equals m plus 3. The next one, it's outside the bracket, so that's a vertical translation, down 4. 1, 2, 3, 4. 1, 2, 3, 4, just below it. 1, 2, 3, 4. So I would get something like this. 1, 2, 3, 4. 1, 2, 3, and 4. And I will get something like that. Try and draw it. Nice smooth curve. We can only be so accurate, but it should be pretty good. Y equals mx minus 4. Harder to do because they're not straight lines. Next one, piecewise, thank goodness. But the difficulty is we have 2. There is a horizontal, there is a vertical. As it turns out, it's probably easier to do these at the same time. So I'm going to move each point 3 to the right and 2 down. So 1, 2, 3, 1, 2. Put a dot. 1, 2, 3, 1, 2. Put a dot. Connect them. 1, 2, 3, 1, 2. Put a dot. Connect them. 1, 2, 3, 1, 2. Put a dot. Connect them. And then finally 1, 2, 3, 1, 2. Connect them. And then I would get this as my, hopefully, my final answer. Again, feel free to use a ruler. Y equals h, x minus 3 minus 2. If I do the next one, horizontal to the left, 4 to the left, and vertical translation 3 up. So 1, 2, 3, 4, 1, 2, 3. Put a dot. 1, 2, 3, 4, 1, 2, 3. Connect them. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And finally, this one, 1, 2, 3, 4, 1, 2, 3. I'm hoping that in all of this, you have noticed we are moving the shapes around, but they are not changing. They look identical, just different locations. Translations do not change the actual function, just its location. Okay, those 2. And we have those 2 now. Next page. Should be this one right here. Oh, shoot. Okay. Sketch it yourself. Well, we're not sketching it, we have a graph. So it's a quadratic. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And on the other side, it's exactly the same, so you can just... Now, I don't know about you, but I find it easier to draw these upside down. I got that. Arrowhead, arrowhead. Am I on the wrong page here? No, I don't think so. Okay, we're moving along. We're doing basic. That's the basic one. I'll do it in color because I like colors. Now, when we do one like this, I'll be looking for the dots. So they should be fairly well done. No scale because I'm too lazy. 2 transformations. Instead of moving the green, I'm going to move the dots. I'm going to move it 4 to the left, down 2. 1, 2, 3, 4, 1, 2. All the other dots should be in the same location. 1, 2, 3, 4. 1, 2, 3, 4. And this one will be over 4, 5, 6, 7, 8, 9. 9. Again, I prefer to have it upside down, and I'd get this. If I've done it right, everything should look identical. The location should be different. And I would label this as y equals x squared, y equals f, x plus 4 minus 2. Up here, I could have simply labeled this as f of x. All right. The next ones. Same thing. My basic function is x squared. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I will get 1 over there, 1 over there, and I get a lovely parabola. Well, it's supposed to be a lovely parabola. I'll label it in a moment. I want to carry out these transformations. 3 to the left, down 2. 1, 2, 3, 1, 2. And again, since it's a parabola, everything is about as symmetrical. 1, 2, 3, 4, and I'll get 4. 5, 6, 7, 8, 9, and then 9. There is no fat, skinny, or normal on this. It makes it easier to draw. Again, I'll be looking for the dots, and you should be going through them more or less. Y equals x squared. This time, I was not given the option, so I cannot use function notation. They want me to put it in standard form. I'm not sure why, but what the heck. X squared plus 6x plus 9 minus 2, x squared plus 6x plus 7. Same thing. Shouldn't be too hard. Next page. To me, this is page 6. All right. I'm going to leave this page. This is for you to do on your own. I want you to draw these 3 on here, these 3, these 3. Bit tedious, but you can do it. Then you should be on to this page. Graph the functions is drawn. The dotted line is the transformation. The dark line is the original. Write the equation. Okay. So this one here, it's a radical. I got it. It looks identical. It's simply been dropped down. So that means the equation would be y equals the square root of x, 1, 2, 3, 4, negative 4, minus 4. The negative 4 should not be under the radical sign. In this one here, this is not a vertical, this is a horizontal. 1, 2, 3, 4. It is moved 4 to the left. So this one, y equals the square root of x plus 4. This one has 2 variations. 1, 2, 3, 4 to the left, 1, 2 up. So this one will be y equals the square root of x plus 4 plus 2. And finally this one, 1, 2, 1, 2, 3, 4. So it's going to be y equals the square root of x plus 2 minus 4. That's what you should be able to do. That's as fast as you should be able to do them. Last page on this particular package. What's the time on this? I can't tell. Anyways, last page. This one here. Don't make a mistake. What's the family? Linear. Oh, for God's sake. Okay, arrowheads, arrowheads. This one here, over 5, down 2. 5 to the left. 1, 2, 3, 4, 5, 1, 2. Now you can do this different ways, but it is a straight line, so my result will be a straight line, and it will be just a straight line. I'm looking for a ruler, to tell you the truth. I don't have one. So it will be a straight line parallel to the one I just drew. So there is my original. I have a ruler, I just can't seem to find it. I could have taken more care. But anyways, here we have f of x. Here we have f of x plus 5 minus 2. Okay, this one, we've done it before. There, there, there. 1, 2, 3, 4, okay, there and there. We get a lovely parabola. We should be getting good at this. This one, translation, 2 to the right, that's what it says, down 5. 1, 2, 1, 2, 3, 4, 5. And then, because it's a parabola, we can just 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll get this one, then we'll get this one. Because they're symmetrical. So we'll get that. And then we'll have that. This should be becoming a bit repetitious. X minus 2 minus 5, f of x. This one, again, it's a different family. It's a radical. So start here. Square root of 1 is 1. Square root of 1, 2, 3, 4 is 2. We get this. This one, I would rewrite it y equals f of x plus 4 minus 3. We like it in that format. So we're going to go 4 to the left, down 3. 1, 2, 3, 4, 1, 2, 3. We get this one, 1, 2, 3, 1, 2, 3, 4, up 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Those we know the square roots of. Not an attractive curve, but what the heck. We prefer to sketch this. Someone's calling, forget the phone. Landlines, go figure. We have this. F of x plus 4 minus 3. And here a quadratic again. Do you think it could be more original than this? 1, 2, 3, 4, 4, and we get this. This one, 2.5 to the left, down. Okay, so 1, 2 and a half, 1, 2, 3, 4, 3 and a half. We go there. Over 1, up 1, over 1, up 1, over 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Where am I now? 9. So I would get something like this. No different than the previous, just a bit more awkward because of the decimals. F of x, and finally f of x plus 2.5 plus 3.5. And I think we are done. Thank you.